All right, I am back with a video for chapter 16. So let's get started. First kind of important term in chapter 16 is the term random variable or sample space. They both kind of mean the same thing. Sample space is a term you may have heard before. A random variable is a variable whose values are possible outcomes of an event. So, um, for like rolling a die, for example, and I think I have this here. Um, a random variable would be one, two, three, four, five, or six, um, since those are the possible outcomes of rolling a standard six-sided die. Um, Kind of going along with that is kind of a step further would be what we call a probability model. And what a probability model is it's not only the possible outcomes or the possible values, but it also contains the corresponding probabilities. So a probability model is the random variable plus all each outcome's corresponding probability. So this is an example. Going back to the die example, this would be a probability model for that. Okay, our possible values for a die are one, two, three, four, five, or six, and then each individual probability is one out of six, right? Because the probability of each individual outcome is one out of six. Okay. One of the important pieces of information about a probability model is what we call its expected value. An expected value is just simply a fancy term for the mean of a probability model. And the way we find the expected value is like it says right here. We multiply each value by its associated probability and adding each product. Multiply each value by its associated probability and adding the product. That's the fancy mathematical notation for it. Here's the example with throwing a die. The expected value would be, look what I did here. I took each possible value of rolling a die, one, two, three, four, five, or six, and I multiplied it by its probability. So 1 times 1 out of 6, 2 times 1 out of 6, 3 times 1 out of 6, so on and so forth. I multiplied each value times its probability, and then I added all those values together, and I got an expected value or a mean of 3.5. Okay, so again, an expected value is take each possible value, each possible outcome, and multiply that by its by its corresponding probability, and then add everything together at the end. Okay, that is what we call expected value. Here's an example that's similar to what you'll see in your Math Excel. I took this from the textbook. This is a random variable. So these are the possible values: 2, 4, 6, or 8. And then the second row is the probability. So what this is saying is the probability of 2 is 0.3. The probability of 4 is 0.4, so on and so forth. And again, the way we find the expected value is by taking each value and multiplying by its probability. So 2 times 0.3, 4 times 0.4, 6 times 0.2, 8 times 0.1, and we add all that together. We multiply that and add it all together, and we get an expected value of 4.2. There'll be a problem similar to this on the Math Excel assignment. Okay. Next type we've already talked about a special type of probability model known as the normal distribution or the normal model. That's, of course, the bell curve. Another special type of probability model is called the binomial distribution. And if you think of what binomial means in algebra, a binomial is an expression that has two terms. Bi means two. Well, in a binomial model or a binomial distribution, there are two possible outcomes. Again, bi meaning two. Now, we call those outcomes success and failure. Now, when I say success and failure, I don't literally mean success and failure. In a binomial model, there is a desired outcome. So we call success if that desired outcome is reached, and we call failure where the desired outcome is not reached. So an example would be like flipping a coin and say my desired outcome is heads. Success would be flipping the coin and it coming up heads. And failure would be flipping a coin and it coming up tails. Okay. Going back to the rolling a die example, maybe my desired outcome maybe would be rolling a 3. So success would be rolling a 3. Failure would be rolling anything other than a 3. So 1, 2, 4, 5, or 6. Okay. The point is, in a binomial model, there are two possible outcomes. Okay. Another characteristic of a binomial model is that the probability of reaching that desired outcome, the probability of success, is the same for each trial. Okay. No matter how many times you flip a coin, the probability will always be 50-50. Okay. If you're using a standard die, the probability of each outcome is always going to be 1 out of 6. That probability does not change no matter how many times you roll the die or flip the coin. Okay. And then the last thing is that the trials are independent of each other. And we've talked about what independent means. Okay. That the result of one trial does not affect the result of future trials. Okay, those are examples of independent trials. Okay, I can roll a die 100 times, and the result of the first time is not going to affect the result of the second time, the third time, the fourth time, etc., etc. Okay, so these are the three main characteristics of a binomial model or a binomial distribution. That there are two outcomes. Probability stays the same for each trial, and then the trials are independent. Okay, and you might remember from way back when that when we did the normal distribution, there was a normal calculator on StatCrunch. Well, on StatCrunch, there's also a binomial calculator, and the way we get to that is simply by doing this. We go stat calculator binomial. Okay, and we're going to be asked to put a certain number of information in. Okay, so in this case, if you remember with the normal calculator, we had to put in the mean and the standard deviation and stuff like that. In this case, we're going to put in the sample size. The n value is the sample size or the number of trials, and then the p-value that we put in is going to be the probability of success. So if you were flipping a coin, the p-value would be 0.5, 50%. Okay. If you were rolling a die, the p-value would be the decimal version of 1 out of 6. Okay. And you could see you could do all sorts of probabilities with it. So it makes more sense if I go through an example. So here's an example of one. This I took from the textbook. A basketball player has a 70% free throw percentage. If he or she takes 5 shots, what's the probability that he or she makes exactly 3 of the 5 shots? Okay. So we'll notice here for the n value is the sample size. You'll notice I put in 5. The sample size is the number of shots he or she is taking. So that's 5. And then the p-value is the probability or the percentage. In this case, it's 70%. And you'll notice that I made this and I made this drop down menu equals, so the probability that he makes exactly 3 out of 5 shots, and I just hit compute and it gives me the answer. Okay. I changed it up to what it same information, but what's the probability that he or she makes at least 3 of his 5 shots? We know, of course, that at least 3 means 3 or more. Okay. So notice when I put that information in, notice my sample size is still 5. My probability is still 70%, 0.7. But notice I changed this right here to greater than. All right, greater than or equal to 3, because 3 or more. And that, of course, changed the answer. Okay. Let's see. What's the probability that he or she makes all 5 shots? Okay. Again, same sample size, same probability. Notice I changed that to equals 5. So the probability that he makes all 5 shots is a little bit under 17%, 0.168. Okay. So that's our PowerPoint. Going back to the Math Excel assignment, I've done the first 7 questions already. Questions 8, 9, and 10 on the Math Excel assignment have to do with Chapter 16. So I'm going to go through those right now to show you how they work. So here is question number 8. Find the expected value of the random variable. Okay, let's open this in StatCrunch. Let's see if this will work. It's not working, it appears. All right, so that's not a problem. But the key is to find the expected value, we take each value and multiply it by its probability. So that means 8 times 0.32. Okay. Then we take, let's see, 18 times 0.47. Oops. Okay. And then we do 26 times 0.21. Okay, so multiply each value by its probability and then add those answers together. So 2.56 plus 8.46 plus 5.46, and we get an expected value of 16.48. Okay, and that's it. That's literally all we have to do. Okay. The last 2 questions, 9 and 10, are basically using that StatCrunch binomial calculator. So let's log into StatCrunch here. Okay. So remember, to access the binomial calculator, we go to Stat, Calculator, Binomial. Just like we did when we were doing the normal, except we're going to do the same thing, except go to binomial. So again, that's Stat, calculators, binomial. And here's our thing here. Okay. So a basketball player who has made 90% of his foul shots during the season gets to take 7 shots in the first playoff game. Okay. So the sample size in this case is going to be, the n value is going to be 7 because he's taking 7 shot attempts, and the probability is going to be 0.9 for 90%. Let me make this bigger. Okay. So that's going to be the n value and the p value for each of these parts. Assuming the shots are independent, what's the probability that he makes exactly 5 of the 7 shots? So we want exactly 7. So we want the probability that he makes 5 out of the 7 shots. Okay. If I compute that, there's my answer right there. What does it say to round to? It says round to 2 decimal places. So that's going to be 0.12. Okay. Probability that he makes exactly 6 shots. So this is going to stay the same. And I'm going to change the 5 to a 6. And we get an answer of 0.37. Okay. The probability that he makes all 7. So again, change the 6 to a 7. And we get 0.48 if we round to 2 decimal places. Okay. And lastly, the probability that he makes at least 5 of his 7 shots. So at least 5 means 5 or more, greater than or equal to. So we're going to go greater than or equal to. We're going to make that a 5. Greater than or equal to 5 means 5 or more, at least 5. Okay. And we compute that and we get 0.97. Okay. And that's it for that question. Okay. Number 10, we're doing the exact same thing. A company chip manufacturer rejects 3% of the chips produced because they fail to work properly. When tested, suppose the company tests 10 chips. So this is the same concept, except instead of taking 10 shot attempts, they're testing 10 chips. So my n value is now 10, and my p-value is going to be 3%, which is 0.03. So A, what's the probability that none of the chips fail? So that would be the same as equals 0. Okay, exactly 0. Okay, and we get an answer. And this time, notice, okay, they want us to round to 4 decimal places. So 0.7374. Okay, always important that we read those directions and that we round to the appropriate number of decimal places. Probability that exactly 1 of the 10 chips fail. So change this to a 1. So 4 decimal places will be 0.2281. Probability that exactly 2, so change the 1 to a 2. So 0.0317. Probability that exactly 3 of the 10 chips fail. So change the 2 to a 3. That's going to be 0.0026. Probability that no more than 3 of the 10 chips fail the test. So no more than 10, okay? No more than 10, does that mean, or excuse me, no more than 3, does that mean 3 or more or 3 or less? Well, no more than 3 means 3 or less. So 3 or less means we want less than or equal to 3, okay? So less than or equal to 3. 3 or less. That's going to be 0.9999. So almost 100%. Okay? And that's it for Chapter 16 and for the assignment. So I've made a video for each part of this unit. You should now be able to go ahead and complete the Chapter 13 through 16 assignment on Math Excel. Obviously, make sure you contact me if you have any questions. I'll be happy to help you in any way possible.